Okay folks, here we go with some questions all about identical resistors. We want to know about the ratio of current in X to current in Y. I love this kind of question. It's a really good test of your understanding of current flow in circuits. It's definitely a challenge. So take your time, and when you're ready to watch the explanation, please press play. Okay, I hope you've had a chance to look at that. Let's go for it. So, first thing to identify here is we've got a pretty tricky circuit. We've got a parallel circuit with a resistor in one branch, then we've got another branch with one resistor splitting into two. So we've got a lot going on here, but we can take our time and we can do it. Okay. First thing is I'm going to call the resistance next, just call it R. Okay, so we've got our resistor R, and they're all identical, so no worries there. We then, on the bottom branch, have got a resistor in series connected with these two in parallel. Now, hopefully, and I've admitted this in this video, I've done it a few times before, hopefully you're aware that if I have two resistors R in parallel, they combine to make R over 2. So the total resistance here is going to be R over 2, plus that R gives you 3R over 2. The reason I've done that is just so we can compare the currents in these two branches. The current going through X and the current going through this resistor here are going to be out by a factor of 3 over 2. Okay? Now, what this means is if we've got a bigger resistance on the bottom, we're going to have a smaller current. It means the current on the bottom is going to be 2/3 of the current going through X. That's our starting point because we want to get to the current in X. Now, we can get rid of, hopefully, that factor of 2. Okay, 2 over 3. Now, the bit that we need to get into is then what happens when we go into Y. These two resistors are equal. So actually, that 2 over 3 IX is going to come out of our resistor here, and it's going to split up. 1/3 is going to go this way, and 1/3 is going to go this way because these two resistors have the same resistance. There's no preference for an approach, and so therefore the same current goes through Y as on the top. That means 1/3 goes this way and another third goes this way. The current in Y is IX divided by 3. We started with 2 over 3, we divide it by 2, we get IX over 3. Why is that relevant? Well, now we can do the division. IX over IY is just IX over IX over 3, which gives me 3, which is why the answer here is 3.